Unit 6.1, Angles of Polygons. We're going to begin this unit with a review of a couple of different skills used to solve quadratic equations. If I look at my first example here, I note that I cannot find factors in -2 that would add up to be 6. So I'm going to get these portions of it, x squared plus 6x, everything that has an x on it, on the left-hand side, and bring the 2 over to the other side by adding 2 to both sides. I then end up with x squared plus 6x plus blank equals 2 plus blank. I put a blank on both sides to remember, or to remind myself, that if I add something to the left side, I have to add the same thing to the right side. The next step is to take the coefficient in front of the x, and I'm going to drop whether it's positive or negative, and divide it by 2. That gives me 3, so I'm going to add 3 squared to both sides. The next step is to bring down the x, whatever sign I have here, which is plus, and then the 3 squared. And the reason I do that is because if I look at x plus 3 squared, that's x plus 3 times x plus 3. Multiplying that out, I have x squared plus 3x plus 3x plus 3 squared. This 3x plus 3x adds together to be the 6x, which is our middle term right here. So I have a perfect square trinomial. That's what I created by adding the 3 squared to the left-hand side. The right-hand side now becomes 2 plus 9, which is 11. The next step is to rad both sides, or square root both sides, so I can eliminate the square here. I have to remember this side will be plus or minus rad 11. So now I have x plus 3 equals plus or minus rad 11. Subtract the 3 over, but it needs to go in front of the plus or minus. So my final answer is x equals -3 plus or minus rad 11. Now remember, when we solve a quadratic equation, we have two solutions. We do have two solutions here. We have x equals -3 minus rad 11. And we also have x equals -3 plus rad 11. Trying it again, we have x squared minus 10x minus 10. I'm going to get these two terms on the same side and add the 10 over. Dividing this middle term by 2, dropping the negative, I'm going to have 5 squared and 5 squared. I have x, I bring down the negative here. So I have x minus 5 squared equals 10 plus 25, which is 35. Square root both sides. Making sure to do the plus or minus on the right-hand side. I now have x minus 5 equals plus or minus rad 35. My final answer is x equals -5 plus or minus rad 35. The other method we have is the quadratic formula, and I want you to be careful on your homework. Read the instructions completely. Some of the problems I'm going to ask you to solve using completing the square, and some of them using the quadratic formula. You need to use the method you're asked to use. So for this one, a lot of you learned it, and you learned it to pop goes the weasel, that x equals -b plus or minus b squared minus 4ac all over 2a. Make sure that it is all over 2a. A is the coefficient in front of the square. B is the coefficient in front of the variable by itself. And C is the constant. So in our first problem here, we have A equals 1, B equals -7, and C equals -3. plugging into the formula, we have x equals negative 7 plus or minus the square root of negative 7 squared minus 4 times a times c all over 2 times a. I recommend that you completely fill that in. Fill it in just like the equation says or the formula says. Then you can do your calculations. That way I can see if your mistake is a simple math mistake or that you didn't understand the formula itself. My next step is x equals 7, because negative is positive, plus or minus. Negative 7 squared is 49. I have a minus here and minus here, so negative times a negative is a positive. 4 times 1 times 3 is 12, all over 2 times 1, which is 2. So x equals 7 plus or minus rad 61 all over 2. So this is my final answer. Again, I have two solutions, 7 plus rad 61 all over 2 and 7 minus rad 61 all over 2. 61 is not a perfect square, so I can leave it underneath of the radical sign. If it was a perfect square, you need to solve it further. So our next one, we have a equals 6, b equals negative 17, c equals 12. So I have x equals negative 17 plus or minus negative 17 squared minus 4 times a times c all over 2 times a. So x equals 17 plus or minus rad. Negative 17 squared is 289. 4 times 6 times 12 is 288. 2 times 6 is 12. I now have x equals 17 plus or minus rad 1 over 12. Rad 1 is 1, so I have 17 plus or minus 1 over 12. I have to continue on this one to show my two different answers because I don't have a rad left. So the first one would be x equals 17 minus 1 over 12, which is 16 over 12. 4 goes into both of those, so it's 4/3. The next one is x equals 17 plus 1 over 12, so that's 18 over 12. 6 goes into both of those, so it would be 3 over 2. So I have x equals 4/3 or x equals 3 over 2. The next one is just looking into how we're going to create the polygon sum conjecture, which means what do the angles of a polygon add up to be? And we'll fill out this chart as we do it. So let's get rid of this stuff here. So if I look at the number of sides, which is what n stands for, the number of sides, if the number of sides in our polygon are 3, we have a triangle. It only forms one triangle, and we already know that the sum of the angles in a triangle add up to be 180 degrees. If I have 4 sides, and I draw one diagonal that goes the opposite, I can't draw to any of the other vertices or angles here because they are the sides. So I have formed 2 triangles. So if I have 4 sides, I have 2 triangles, and the sum of the measures of the interior angles would be 180 plus 180, which is 360. On 5, I can't draw to this side from here from that, so I have that, and I have this one. So I have 1, 2, 3 triangles that were formed, and the sum of the angles would be 540. So that would be 180 plus 180 plus 180. For 6 sides, I have 1, 2, 3, 4 triangles. So 4 triangles, that would be 360 times 360, so that would be 720. Seven sides, I have 1, 2, 3, 4, 5 triangles. Adding 180 to 720, I have 900. For 8, I have 1, 2, 3, 4, 5 diagonals that I could draw, and 6 triangles. Adding 180 to 900, I would have 1080. 9 sides, we don't have a picture for that, so let's just skip to 10 sides. Draw your diagonals. One, two, three, 4, 5, 6, 7, 8 triangles. So I can assume that 9 would have 7 triangles. Adding 180 to that, I would get 1260. Add 180 to that again, I get 1440. 11 would have 9 triangles. 1620. 12 would have 10 triangles, which would be 1800. We're going to leave this last column here blank for a few minutes. If I look at this, for each polygon, compare the number of triangles to the number of sides. So if our number of sides here was 3, and then our number of triangles was 2, with 4, the number of triangles was 2, with 3, the number of triangles was 1, with 4, the number of triangles was 2, 5 sides, the number of triangles are 3. So looking at it, the number of triangles would be the number of sides minus 2. So the number of sides, which we let n be the number of sides, minus 2. That's what goes up here. N minus 2. How does the number of triangles created by the diagonals in each polygon determine the number or the sum of the interior angle measures? It's the number of triangles times 180. So filling this out up here would be n minus 2 times 180. So our interior angle sum would be n minus 2 times 180. So it doesn't matter how many sides we're looking for. For example, if we look for 10, we would do 10 minus 2, which is 8, and then times 180, if we're looking for 12, we do 12 minus 2, which gives us 10, and 10 times 180 would give us 1800. Find the sum of the measures of the interior angles of a 23gon. You would do 23 minus 2 times 180, which would give us 21 times 180, which would give us 3,780. Here we know what the sum of the interior angles is. It's 3,240, but we don't know the number of sides. We know that the sum would be n minus 2 times 180. We know the sum is 3240. The easiest way to do this would be to divide first both sides by 180. We'd have n minus 2 equals 18, and then we would add 2 to both sides, and we have n equals 20. The next question asks us, what is the measure of one interior angle in an equal angular heptagon? When all the angles are equal, all the sides are equal, so this is called regular. Looking at this, we have 1, 2, 3, 4, 5, 6, 7 sides, or 7 angles. So with 7 sides, we would do 7 minus 2 times 180, which would give us 900 degrees. But all the angles are equal, so we could do 900 divided by 7, which gives us at each angle would be 128.57 degrees. Looking at what we just did to find one angle in a regular polygon, we did n minus 2 times 180 divided by the number of sides to get the one angle. There will be different ways to do it on the homework. You can do it this way, or I'll show you a couple examples of the homework problems where we can take a couple shortcuts. Because we'll bring into play the last thing we're learning here. It doesn't matter how many sides there are or how many angles there are in a polygon. The exterior angles will always add up to be 360 degrees. And what we're looking at for exterior angles is if I look at this picture here and I extend the sides, the exterior angles we are looking at are right here. So we also know that the interior angle plus the exterior angle next to it equals 180, and we'll use that a lot. But the exterior angles, you could have 3 sides, and the exterior angles will add up to be 360 degrees. You could have 1,000 sides, and the angles for the exterior angles will also add up to be 360 degrees. So for our summary, we have the sum of the measures of the interior angles, or the number of sides minus 2 times 180. The measure of each interior angle of a regular n-gon is n minus 2 times 180 divided by n. The exterior angles of any polygon will always add up to be 360 degrees. Just to give you an example, a couple of the coursework or homework problems that we're looking at. Let's look at the first problem right here. 11-gon, we have 11 sides, so it's going to be 11 minus 2 times 180. So 9 times 180, which would give us an answer of 1,620 degrees. The measure of an interior angle of a regular polygon is given. Find the number of sides in the polygon. The easiest way to do this is to find the exterior angle. So to find the exterior angle, we know the interior and the exterior angle add up to be 180. Looking at this picture again, here's an exterior angle, here's the interior angle. They form a line, so they add up to be 180. So I would do 180 minus 144, and that would give me 36 degrees as the exterior angle. All the exterior angles add up to be 360 degrees, so we'll divide it by one of them, and we would have 10 sides. For 7 and 8, We have quadrilaterals. We have 4 sides. We know all the angles add up to be 360. So add each one of these angles up, set them equal to 360, find your x, and then plug it back in to find each angle. For the following 6 problems, the easiest way to do this is to find the exterior angle first, then find the interior. So here we know we have 16 sides. We know it's a regular polygon. So all the exterior angles add up to be 360. Divided by 16. And you would have that the exterior angle is 22.5 degrees. And this is the exterior angle. To find the interior angle, you would do 180 minus 22.5 degrees, and you would have 157.5 degrees as your interior angle. And that's how you're going to do problems 9 through 14. For the first 6 problems right here, you're going to do it by completing the square, not the quadratic formula. For the next 4 problems after that, you're going to do the quadratic formula. And that concludes our lesson for 6-1.